This is the presentation on Janitor. Janitor is a Clojure Devops Swiss Army knife, and I'm gonna talk about the evolution of that tool. My name is Yrjö. I work as a software engineer at Tomorrow Tech, which is a startup and a product studio where we're building Dias. Dias is a digital trading platform for the residential real estate market in Finland. And the two main points in this presentation I'm going to make are that Docker and Clojure are really awesome for DevOps command line tooling. And the other point is that I'm going to discuss the journey that led us there and what did we learn during the 1 year we've been actually running the product in production now, and also building our DevOps tooling. But before I start, let's recap what does DevOps mean, because different people have really different ideas on that. For the sake of this presentation, and in my opinion, DevOps means that our development teams also takes care of all the operations work. So it means that they do all the necessary steps in getting new features up and running into all server environments, as well as doing the maintenance work to keep the server environments working and up to date. So in Dias, the technology platform, or the relevant parts for this presentation are firstly Azure and Kubernetes. We're running our software in AKS, which is Azure Kubernetes Service. Also, we're using a lot of other Azure services. One of the biggest one is PostgreSQL. And the programming languages we mainly use are Clojure and Kotlin. So this is basically the background. And Kubernetes, PostgreSQL and Clojure were familiar tools for the team before building this platform. Azure and Kotlin were something that we had to really learn along the way. And while we are using these platforms, these cloud services, the standard tooling that we used to get things up and running were Helm and ARM templates. Helm is the Kubernetes package manager, which uses Helm packages from Helm charts and Go templates in YAML format to describe what should be running up and running in what environment. And the ARM templates are the Azure infrastructure as code solution. So they are basically files in JSON format which have specific template expressions that can be written as JSON strings. We call it the JSON programming. And it can be generated in the Azure portal web UI, and these can be deployed using the Azure command line tool. And there's a lot of other tools for it, especially on the PowerShell. But since our team is not using Windows, we're not having easy access to all of those tools. But then these are just the most basic building blocks. And then in addition to that, we need to do a lot of other kind of DevOps operations. And for that, we need a lot of automation tools to be a fast-paced development team to get things done. But then again, we're a startup, so it means that we really cannot afford developing all this tooling on the first day. So basically, we have been building these incrementally. So the things that we need to be able to automate is things around the deployments, in addition to the Helm tooling. So like having version management on what container version goes where, some network traffic tooling on helping out with what can connect where and how to block traffic and stuff like that. One big part of DevOps tooling is managing configurations and secrets, sometimes directly in environment variables, sometimes first going to Azure Key Vault secrets, and then from there to Kubernetes, and from there to the Docker containers. And also all of these managed in version control, so that we have kind of clear understanding on what is running on which cloud environment, which server environment. And then we need, of course, logging, monitoring, system testing, which means that recurring automatic tests to see that our APIs are working correctly. And then manual administrative tasks. That means that we have internal APIs that handle some operations that cannot be done by the normal user interfaces of the system. There's also a lot of other small tasks, but here's like some main needs that we have been seeing that, okay, these need proper tooling. So how does teams usually start automating DevOps tooling? One obvious solution is to write bash scripts, and that's how we started as well. It's of course nice to start with bash because it's really fast to create bash scripts, because you basically have built-in support that's in your server environment and you have it on your command line, and it's easy to compose your command line tooling together, for example Kubernetes tooling and version control stuff. But obviously it's not really good for general purpose programming, and since it's not compiled, it's really error prone, even if you have all the strict checks set on. So you have these set flags to control the behavior during failures, but it's still a bit hassle. Parallel execution inside bash is really hard to do right if you have to clean up stuff that's running simultaneously and stuff like that. The dependency management is also hard. Like, how do you know that you have always the right versions of the tools installed? We often had the problem earlier that some developers had updated their homebrew, and then they had different version, and then suddenly some stuff stopped working, and then we saw that we have a dependency to a specific version of a specific tool. And then it's a bit cumbersome to do test automation. Okay, you can use tools like robot framework, but it's not really a built-in thing in bash. So then we started thinking, we're doing a lot of manual things with bash scripts here and there, but when the number of users in our platform grew, our team saw that, okay, now there's so much recurring stuff that's just like running this bash script and then the other bash script. Instead, we could have a proper tool. And one developer in our team was really frustrated with those things, and there was like editing customer information in EDN files by hand and using bash scripts to upload them in Azure Key Vault. And then they decided to create a tool that would automate as much as possible, check the data integrity and integrate it to Azure Key Vault. So they started like thinking, okay, let's use some kind of better programming language, and hey, why not use Python? Python is nice, and there's like a good library. There's Azure library, so let's do it. There's unit tests. Okay, we can write those, and it's really lightweight to start up on the command line. But then again, it's one drawback is that it's really different on the other languages that on our platform. So in comparison to Kotlin and Clojure, you need a completely different mindset in writing Python, and most of the team were not that familiar with all the details of writing Python. And then we had also the issue on, okay, how do we get the right Python environment for everybody? Firstly, to even run the tool, and then to get all the kind of development, possible development environment for everybody. So a bit hassle for just one tool. So it was a really good progression for us. We had really much better tool. It's really good tool, but a lot of hassle as well. So then we started like discussing as a team, like, okay, where do we want to go from here? Is it like more Python, or everybody picks whatever language when they want to do better tooling than the bash scripts that we mainly had at that point? And then we thought, okay, we'd like to really stick to Clojure, and then we looked into Clojure. Is there anything like command-friendly stuff for Clojure? And we find out there's this Clojure for command line called Plank. Plank is a standalone Clojure script REPL for Mac OS and Linux. It really launches instantly, and it's really useful for scripting. Okay, looks good. Let's start automating our shell scripts with a nicer programming language. And it's familiar to us, and it has really excellent EDN interop, of course. So almost all of our internal configurations are in EDN format, so this is nice. It has a very fast startup time, and you can handle the dependencies and script execution via shebang syntax, so you can easily write a command line script like an independent script file that is just run if you have a Plank interpreter in your path. And we wrote also unit tests with CLJS test runner. It has also Plank support, and obviously it offers a REPL, so it's much nicer with a Clojure kind of a REPL to do development. But then Plank has its drawbacks as well. It doesn't really cover the whole Clojure core. It has pretty much all stuff for, let's say, simple and straightforward scripting needs, but when our needs also grew, we kind of found out that, okay, there are parts that are a bit different from Clojure, and then there are some stuff that's missing. And okay, it was another command line tool like Python. We had a new version dependency. And then again, while you can get the libraries that are built as jar files via boot, or then CLJS libraries, we were a bit unsure whether it really has those libraries that we will need in the longer run. So when we wanted to do more complex DevOps tooling that would combine like using Kubernetes and Azuur and Docker, we were all again thinking, is this the right tool for us? And then we thought, okay, maybe we could have a better tool that would actually solve all those previous problems. And one developer in our team actually started using some stuff on the Java SDK of Azuur and started trying out, okay, can I use Clojure to actually call these Java SDKs? Would that be actually much more efficient than trying to find out the libraries for Plank or Python and then doing all the hassle of figuring out how to handle all the version management or the dependency management for those, because we already had like all the kind of tooling and know how to do stuff on Clojure. So then we tried out Clojure and JVM. Obviously, we like this language, so why not try out the real Clojure? It has all the core functions that we actually want, and it really has really wide library support, and it's much easier for us to actually get all that power, like Kubernetes, Docker, Azure, etc. And it also has really good HTTP clients, so many kinds of clients, and we could use that for other kinds of API access. So we also use, for example, Datadog API via HTTP. It has really nice support for asynchronous programming, which we used for some networking tasks, such as port forwarding. It has really good tooling for automated tests, and of course it interoperates obviously also nicely with our EDN configuration files. And of course the CLJ REPL is really good, so it's even better than the Plunk REPL, and all this integrates really much better in our editors, for example, and with linting and stuff like that. So for example, we already had set up everybody have REPLs running in their editors and all that stuff. Now it just works. There was also some drawbacks, for example, with the Azure SDKs. There was quite poor documentation, but then we found out a nice way to handle this. So we loaded a Java project in our IDE, for example, IntelliJ, and then that way we could just use that for traversing the Java code to figure out what API calls we should use for each task that we needed to use. And that was actually very nice. Then we could just call it in Clojure in the way that we could see it from the IDE, what was like available in the API. And this is a really nice tip for any kind of library that is not properly documented, but you know that, okay, it really handles on the Java SDK part all the stuff that you need. So just check out in any nice IDE what does it like show from the jar file, what can you find there. Okay, then we ended up building a tool around all that. So we call this tool CLJ Azuur. So that's actually the DevOps command line tool we have now, and it's organized in this way that there's two kinds of operations. There's jobs and tasks. The jobs are run without human interaction via Azure pipelines, so they are basically automation that reads a configuration and performs one job that basically combines many kinds of operations in one bundle. And then the tasks are basically tasks that are run by humans on a command line, and they are run inside an environment specific Docker container, so that they always have the same parameterization on how to kind of get the right credentials, for example, for Azure or Kubernetes. And all of these operations have dry runs, so they offer a way to test them. There's unit tests and also common handling of command line arguments. So it's a nice way to bundle all these kind of operations in one tool. And one of the things, well, here's an example on how it works. Like this is called deploy databases, and this is example of the job type of operation where there's like actually several operations and they are bundled together like this. So first we read and validate an EDN configuration, and then we use Plomatic schema to validate it, make sure that it doesn't allow non-valid IP addresses or non-valid Azure identifiers, because there's sometimes limitations on the characters you can use or how long they are. Then it will read stuff from Azure Key Vault using the Azure SDK, Java SDK. Then we have our EDN templates, which basically replace the ARM templates. But the fact here is that if we would use the generic ARM template, those would be made for any kind of Azure service to configure it in all possible ways, but now we can reduce them to a more specific set of operations we can do with this tool. So it's like really specific for our platform needs. And then when we deploy those templates, so basically we read EDN in and create the same kind of JSON stuff that Azure portal as well creates. And then we deploy them again using the Azure Java SDK. And after that, basically after the deployment, there's some new database services that we can use. And after that, we can connect to those databases. The servers create more databases there, create users, create roles. So obviously we use JDBC for that. And this is another client that we have written inside CLJ Azure. So we basically have different kind of parts there that we can then use in different jobs. And this is how it looks like in terms of the EDN configuration. So we can have really small and concise configuration for just those stuff that is relevant for us, and we don't need to expose all the parameters that the ARM templates will have to use. And then we can also use the nice schema validation in between. Okay, so then how about the startup time? I think one of the reasons why we didn't just use Clojure in the first place was that we were a bit afraid of startup time and how to kind of how efficient would it be to use Clojure on the command line. But then we actually found out that it's pretty fast. I'm usually thinking of Clojure execution as running it through line run, which is not that fast, but that's what I compare it when I think about the developer experience. But our tool is compiled, so it's actually really fast. And when I run one task that is called merge EDN, which basically takes several configuration files together, and I made a bigger bunch of configuration that I combined, and it took pretty much the same time on the plank as it took with the JVM. And for some reason it was faster inside the Docker container than on my Mac OS X. And then the operations that we typically run do things over network connection. So they connect to Azure and Kubernetes and Datadog. So the JVM startup time is actually not that significant there. And also we usually compose the bigger, more complex jobs from libraries and clients inside CLJ Azure. So it's not like combining them in the Unix way that we would run many times the whole JVM. So that's how we also make it a bit more efficient. And then we wanted to combine all the tools that we had accumulated this far together. So we created this Devops Docker environment, which is now called Janitor. So Janitor is a way for us to put everything in one bundle. Now we have bash stuff, and we have like common bash scripts, we have environment specific bash scripts, then we have all these command line tools that we need, and we want to have the same version running for everyone. And we don't want to have it, not everybody needs to install all these tools on their own laptops, because we can use them in Docker. And now we can also make sure that everybody have the same versions. And then we have like separated startup context for each of our server environments. So we have 4 environments, and all of them have different configurations available for them. And this way the Docker can be started, Docker container called Janitor can be started so that it mounts from our configuration Git repository just the right stuff for that specific environment. And then one thing that we also wanted to do is to have the production context run from a different container registry. So then we needed to also promote the tooling between production and the other environments, so that all the tooling that we develop in the dev, demo, and test environment will be then promoted to prod when we know that it's working. So the pros and cons in doing this Janitor approach with Docker is that, as I said, we can do the Azure command line tool login session inside the Docker, and also all the Kubernetes credentials. We don't need to have them on our local command line at all. And when we exit the Docker container, the login session is closed as well, so it's much more secure. And also we can log into multiple server environments at the same time, because we can run the same container from different contexts. And that way we don't have like a global Azure login, for example, because if you do Azure login on your command line, then you're stuck on that account, and you need to kind of log out if you want to log into another account. But now when we do it inside Docker, it's nicely containerized. And then we have all the environment specific parameters, as I just said. So it's kind of it's impossible to have the you're connected to the wrong environment with another environment's configurations. That's basically impossible, because we can only start the Janitor container from the environment specific path in our configuration Git repository. Obviously you could do that by hand from some other contexts, but this is the way it's meant to use, and it's scripted to be used like that. And now the same tooling that we use locally on our laptops can also be used anywhere else, for example in the CI pipelines, and we can automate easily tasks that can be run on server that have the same context as we would have locally. Some of the cons then are that not all the tools that we use are available. We couldn't even get Plunk compiled for Alpine, so then we ended up using Ubuntu, and that means also that our image is pretty big. So it's now the Ubuntu image of Janitor that contains all the tooling that we wanted to have is 2 gigabytes. So when we are developing Janitor, we need to build new Docker containers and upload them and download them, and then when somebody wanted to do a deployment for some environment, they might need to first download new version of Janitor Docker image, and obviously this is can get heavy if you're on the road using 4G, or in some cases your home internet connection, if you're, for example, stuck doing remote work because of COVID-19. And then one interesting part was learning the kind of promotion task, how to get that working, because we are using different container registries for Docker images, and we promote them from one container registry to another using Janitor. That's all okay, but since Janitor itself is also a Docker image, how would we then promote Janitor itself with Janitor? And then this is just a nice way to do it. So we can use inside Janitor. So inside the running container, we can use Docker APIs programmatically to pull and push images. And if we mount the Docker socket inside the Docker container, then we can use the host Docker daemon to perform that task. So this was the trick on how to do it. So after we learned to do this, we found out that we felt that you can basically do whatever with Docker. And yeah, I think that's mostly the stuff that I wanted to tell. So as a summary, Docker gives us really nicely unified environments and tools and versions. of all the stuff that we need, and it separates nicely different server environments and their configurations. It wraps the login sessions inside the containers so that they don't leave, for example, a production session ever open on your local laptop, because it's never open on your local laptop. You just use it for the container, inside the container. And Ubuntu was very nice because we could get all the stuff we needed installed there, but it's quite massive. So one of our task in our Devops backlog is minimizing the Docker container, but let's see. And then again, Clojure, we of course knew that it's nice, but it was a surprise for us how nice it's also on command line. So it was nice to start developing a command line tool for Clojure as well. The library support is awesome, and the only challenge there is that now that we have tooling also on Bash, on Python, on Plunk, it takes quite a lot of time for startup, because to get all that stuff moved to Clojure. So we don't really have just one tool, but we have now a set of different tools, and maybe at some point we'll get rid of some of those. And also, since we have lots of nice things done in Bash, it's really easy to fall back to just copy paste the old stuff, and we need to always, when we start new maintenance things, we need to kind of think about the trade-off on how much time should I spend on developing a better tool versus how fast does this thing need to be done, and how often is it used. So that's it. Thank you. And now in the meetup we'll continue with the Q&A.